Imagine a single line of hard-coded text, just one.
Yeah.
Like just one outdated email address that's buried deep inside this, legacy workflow script.
Oh, I know exactly where this is going.
Right. And it brings a multi-million-dollar global supply chain to a dead halt. I mean, the warehouse is packed, trucks are waiting at the docks.
But the purchase orders just aren't moving.
Exactly, because the system is desperately trying to route approvals to a manager who left the company 3 weeks ago.
It happens so much more often than anyone in enterprise IT wants to admit. I
Yeah.
mean, when you hard code your business logic into the core code of your automated processes, you're essentially building a time bomb.
A total time bomb. And diffusing that bomb is exactly what we're focusing on today. So welcome to the deep dive.
Glad to be here.
We are looking at the advanced architecture of SAP Build Process Automation today, and our mission for this session is highly specific.
Very specific. No fluff today.
Zero fluff. We are bypassing all the generic buzzwords about, digital transformation paradigms.
All right, we've got a stack of official SAP course modules right in front of us, and we are going straight into the weeds.
We are talking API encapsulation, business decision modeling, process execution, and REST APIs. I mean, this is a practical, technical walkthrough. It's designed to help you architect systems that don't just break when the real world changes.
Yeah, because the shift we're talking about here, it's about moving away from monolithic, rigid scripts.
Toward a composable enterprise architecture.
Exactly. It's about really understanding the fundamental mechanics of how data flows, how choices are made dynamically, and how you monitor the entire apparatus without just drowning in server logs.
Right. And to set the stage for how we're going to approach all these SAP course materials, I want you to visualize building an automated process constructing a highly advanced, fully autonomous smart factory.
Okay, I like that analogy.
Yeah, because you can't just drop a bunch of robots on an empty floor and expect a finished product to pop out.
No, you need infrastructure first. Okay.
Right. First, you need supply lines to bring in the raw materials from the outside world. And
Okay.
those are your APIs.
Make sense?
Then you need quality control checkpoints that can dynamically route those materials based on, specific weight, size, or destination.
Which represents your decision logic.
Exactly. And finally, you need a centralized, glass-walled control room where supervisors can actually see the factory floor in real time.
And intervene if they have to.
Right, which represents your visibility scenarios and your REST APIs.
You know, the genius of modern SAP Build Process Automation is really how it modularizes those three distinct factory components.
How so?
Well, in older paradigms, developers would write one massive script that fetched the external data, evaluated that data against the business rules, and then triggered the next steps.
Just a giant monolith.
A total monolith. But now, you build the supply pipe once, you define the rules once, and you can plug them into like 50 different factory floors across your ecosystem.
That's incredible. So let's start with those supply lines. The blueprints we have here dedicate a massive amount of focus to integration.
Right, specifically connecting remote systems like SAP S/4HANA to your automation environment.
But the course material is explicit here. It says you do not just write a raw API call directly into the middle of your process flow.
No, absolutely not.
You're supposed to use something called an actions project. So let's unpack the mechanics of that.
Sure. So in any enterprise environment, your business process management system has to talk to external systems.
Right.
If an automation is handling order fulfillment, it needs to pull real-time sales order data from an ERP like S/4HANA.
Right, and it does that via application programming interfaces, APIs.
Exactly. But embedding that raw API call into the process flow it's dangerous and inefficient. Instead, you encapsulate the API.
Meaning you just put a wrapper around it.
Exactly. You take an open API specification.
Which is a standardized JSON format, right?
Yeah. It's a JSON format that dictates exactly how a specific API behaves, what parameters it accepts, and what data it returns.
Okay.
And you define it as an action within SAP Build. You're basically creating a custom, reusable widget.
So as an architect designing this environment, why enforce this encapsulation? Like, why create this extra layer of administrative work instead of just letting the developer ping the S/4HANA endpoint directly?
It fundamentally comes down to abstraction and security.
Okay, walk me through that.
By wrapping the API into an actions project, you create a literal firewall between the back-end system and the process developers.
Ah, I see.
The developer building the day-to-day workflows, they shouldn't need to know the underlying technical intricacies of S/4HANA's data models.
Right, they shouldn't have to worry about complex JSON payload structuring.
Or specific authentication headers, exactly. They just open their library, see a clean, business-readable widget called Read Sales Order, and they just drag it onto their canvas.
And the security implications there are massive.
Oh, huge.
Because you aren't handing process developers the keys to the entire S/4HANA kingdom.
No, you are acting as the gatekeeper.
Right. You're only exposing the exact endpoints and the exact data fields that are strictly necessary for their specific automation.
It's the principle of least privilege, but applied to API management. Plus, think about the life cycle of enterprise software.
Right. S/4HANA is going to get updated eventually.
Yeah, API versions are going to get deprecated. If you have 50 different automated workflows that all have raw API calls hard-coded into them.
Oh, wow. Then an API update means you have to hunt down all 50 workflows.
Yep. Rewrite the code, test them all, and redeploy every single one.
Yeah.
But if you use an actions project, you update the wrapper in one single place.
And the translation happens inside the action.
Exactly. And all 50 dependent processes just keep running without skipping a beat.
Okay, let's get into the actual construction of this. If you are listening and building this out, the first place you need to go is the SAP Business Accelerator Hub.
Right. That's the central nerve center for SAP's prepackaged integrations and API definitions.
And you'll want to filter your search specifically for SAP S/4HANA Cloud Public Edition.
Yeah, and once you've filtered the environment, you are looking for a very specific set of endpoints. You want to search for Sales Order A2X.
Sales Order A2X, got it.
When you view that API documentation, you'll have the option to download the API specifications. You want to grab the JSON file.
That's the one typically named apicel sorters rv.json, right?
That's the one. That file contains the entire schema of how to interact with sales orders in that backend system.
Okay, so you take that JSON file, you switch back over to your SAP Build Apps environment, you navigate to integration sources, and choose to upload API specification.
Right.
You drop that file in and name the project SAP S/4HANA Sales Order Actions. But here's where we hit a critical design decision in the source material.
Oh, this is a big one.
Yeah, and it is all about data minimization.
This is where a lot of less experienced architects really shoot themselves in the foot.
Oh, so
Well, when you add the sales order header to your action, which is the specific endpoint that reads the top-level data of a sales order, the system is going to show you a massive list of output fields.
because S/4HANA stores an incredible amount of metadata for every single order.
Exactly.
And the documentation explicitly instructs us to go into that output section, select everything, and systematically remove the keys we don't need.
You have to be ruthless about it.
It lists specific fields you have to search for and delete. Let me read them off. Organization division, distribution channel, total net amount, sales order type, sales order date, unchecked purchase order by shipped party, sales organization, and requested delivery D.
Right. You're supposed to uncheck all of those, remove them, and save.
Wait, I have to pause here. As a developer, my natural instinct is to just grab everything the API offers.
Oh, I totally get that.
Right. I mean, if I'm already opening the connection and pulling the record from the back end, why go through the tedious manual process of stripping out all these specific fields?
It seems like extra work for no reason.
Doesn't carrying more data give me more flexibility later? Like, if I keep the requested delivery D field, maybe the business will ask for a delivery date check next week, and I'll already have the data in my process.
It's a totally understandable instinct, but in a cloud-based microservices architecture, it's a fatal trap.
Wait, really? A fatal trap?
Honestly, yes. Passing massive unnecessary data arrays completely throttles your process execution.
Oh.
You have to remember that every kilobyte of data that moves from the S/4HANA backend into your active process memory requires network bandwidth, compute power, and memory allocation.
So if I'm processing one sales order, it probably doesn't matter.
Right. But if the automation scales...
Oh, if you're processing 10,000 sales orders an hour during a peak retail event?
Exactly. That extra flexibility suddenly becomes a catastrophic performance bottleneck. You're forcing the system to serialize, transmit, parse, and hold on to millions of data points that the workflow is never actually going to use.
So we are talking about strict payload optimization here.
Precisely. And it circles back to security and compliance as well. You only want the process memory to hold the data strictly necessary for the business decision being made at that exact moment.
Makes sense.
If the automated process only needs the total cost of the order and the shipping country to determine which manager needs to approve it, There is absolutely zero justification for pulling the customer's internal distribution channel or regional sales organization data into the active workflow.
Because a smaller footprint means a faster process and a reduced attack surface.
Exactly.
That makes a lot of sense. Okay, so we trim the fat. We now have this lean, optimized actions project sitting in our workbench.
Yep.
But a pipe isn't useful until it's connected to a water source.
Yeah.
How do we actually hook this up and test it without, accidentally firing test data into our live production environment?
Right, to safely test this, you have to understand the concept of a destination within the SAP Business Technology Platform, or BTP.
Okay, what's a destination?
It's essentially the technical routing address of the remote system you're trying to connect to. But it's much more than just a URL string.
What else is it?
It's a secure vault. It holds the authentication credentials, the certificates, and the authorization protocols required to talk to that specific system.
But again, if we're just learning the architecture and building our initial models, we shouldn't be pointing destinations at a live ERP.
Never, never, ever. For development and testing, SAP provides an API sandbox environment through the Business Accelerator Hub.
Oh, that's handy.
Yeah, it acts as a proxy. It's a completely safe, isolated playground where you can fire off API calls and get realistic mock data back without ever touching real corporate assets.
So let's walk through what it takes to actually configure and validate this connection.
Let's do it.
Inside the Actions project you just built, there is a Tryout tab. You navigate there and select the specific endpoint you want to test.
Which in our case is get a sales order.
Right. It will ask for a value for the sales order number. And if you just enter the string value of 1, you are telling the sandbox to return the very first piece of mock data it has on file.
But the sandbox won't just talk to anyone. You still need to authenticate.
Right.
If you go back to the Business Accelerator Hub where you originally found the S/4HANA API, you will find a button labeled Show API Key.
And when you click that, it generates a long string of cryptographic characters.
Exactly. You copy that key and head back to your Actions project. In the Input section, you need to add a new field. You name the key AP Key.
AP Key, one word.
Yep. And here is a vital configuration step. You must set the parameter type for this field to header. Then you paste that long cryptographic string into the value field.
I want to dig into that specific parameter type really quickly. Why are we passing this API key in the header? Like, why not just append it to the end of the URL or drop it into the main body of the JSON request?
That is a fundamental HTTP architecture standard. The header is the secure, designated space for passing authentication tokens and metadata. If you append an API key to a URL, as a query parameter, for instance, that URL gets logged by every web server, every proxy, and every firewall router along the network path.
Oh, wow. So anyone with access to those network logs can just scrape your API key and impersonate your system?
Exactly. It's a massive security vulnerability.
And the body of the request, why not put it there?
The body is meant strictly for the actual data payload, the business data you are creating or modifying.
Ah.
The header acts like the sealed envelope containing your credentials. It tells the receiving server, here is my ID badge. I am authorized to open this connection. It keeps the authentication totally separate from the payload.
So the key is securely in the header. Next, we need to route the request to the sandbox.
Right. We add another input parameter for the URL and point it to the sandbox environment address provided in the SAP documentation.
And once the routing and authentication are set, you run the manual test?
Yep. You hit execute, pass the string value of 1, and review the output preview.
And if the configuration is correct, you'll see the JSON response populate with the header values of that mock sales order.
Exactly. That confirms the pipe works.
But the final step to make this usable for the rest of the enterprise is to release it.
Right. You hit release, which takes a version snapshot of the project.
You add your release notes, something descriptive like reads the header of the S/4HANA sales order.
And then, crucially, you must hit Publish to Library.
Publish to library. Why is that step so critical?
That Publish button is the bridge between the API architect and the process developer. Until you publish, that action is just a draft sitting locally on your personal workbench.
Ah, so no one else can see it.
Right. Publishing is what pushes it into the central repository, making it available for developers to just drag and drop onto their process canvases.
And when a developer does drag that action step into their process, they only have to configure 3 things.
Yep, just 3. First, they assign a destination variable.
This is a dynamic placeholder that gets filled with the actual production system address when the process is eventually deployed.
Exactly. Second, they map the inputs. taking data that already exists in their process memory, like a sales order number submitted on a form, and feeding it into the API parameters.
And third, they map the outputs, taking the data the API returns and saving it back into the process memory for the next steps to use.
Spot on.
So let's take a step back and look at what we've built here. We have a highly secure, optimized, abstracted pipe that can pull specific sales order data from an S/4HANA system right into our automated workflow.
Yep.
The data is sitting there in our process, but a workflow that just fetches data and holds it is completely useless. We have to do something with it.
Exactly. Data is completely passive. A business process requires action, and action fundamentally requires choice.
We need the system to evaluate that incoming data and make strategic decisions based on it without a human having to look at a screen.
Which transitions us perfectly into the next major pillar of the architecture, business decision modeling.
All right, let's get into it.
If you are going to automate a complex workflow, you have to find a way to codify the rules that govern your business. SAP Build provides a highly structured capability to model and manage this logic.
But before we build anything, we need to get the vocabulary straight, because the hierarchy of how this logic is organized is very specific.
Extremely specific. Let's lay out the taxonomy.
Okay, at the highest level, a business project contains decisions.
Right. A decision is a discrete architectural object that is mapped to specific input data types and exactly one output data type.
It's the box that takes data in, evaluates it, and spits a result out.
That's the container, yeah.
Yeah.
Inside that decision, you have one or more policies.
Okay, what's a policy?
You can think of a policy as a localized grouping or a collection of logic. And finally, inside each policy, you have the rules.
The rules.
The rules are the actual granular, micro-level decision-making artifacts. They're the individual algorithms that get executed in a strict, predefined sequence to reach the final output.
Okay, I want to try an analogy here to make sure this hierarchy makes sense in a real-world context.
Record it.
Let's say you are running an incredibly exclusive, high-end nightclub.
Okay.
The decision object is the bouncer standing at the front door. The bouncer has one job: take an input, the guest trying to get in and provide an output, access granted or access denied.
That works perfectly.
So the policy is the physical clipboard the bouncer is holding. It's the official framework provided by the club's management for that specific night.
Right.
And the rules are the actual handwritten lines on the clipboard. Line 1, if the guest is wearing sneakers, deny entry. Line 2, if the guest is on the VIP list, grant entry. Line 3, if the guest is accompanied by a member, grant entry.
I love that analogy because it perfectly illustrates the greatest benefit of this architecture.
Which is?
The complete separation of concerns. In our factory model, the bouncer represents the decision step integrated into your process flow. The bouncer themselves never changes. They just stand at the door, read the data, and execute the clipboard. Now imagine if nightclub management decides tomorrow that sneakers are actually high fashion and they want to start allowing them.
Okay.
Because the rules are decoupled from the core process, they don't have to fire the bouncer and hire a new one. They don't have to rebuild the entrance of the club. They literally just erase line 1 on the clipboard.
So the underlying infrastructure remains entirely untouched.
Exactly. Translated to enterprise software, this empowers business users, the people who actually understand the market dynamics, to manage their own logic.
Oh, I see.
If a finance manager needs to change an automatic approval threshold from $10,000 to $50,000 because of inflation, they can go into the decision table and update the rule themselves.
They do not need to submit an IT ticket and wait for a developer to rewrite the core process code, run regression testing, and redeploy the entire application.
No, not at all. It creates incredible organizational agility.
When you are architecting this in the SAP system, you manage all of this through a visual layout called the decision diagram.
Right. It acts as a high-level flowchart, mapping the execution path of the logic from input to output.
It gives you a bird's eye view of what data types are involved and what rules live inside which policies.
And when you actually drill down and write the logic itself, SAP gives you 2 distinct formats.
What's the first one?
The first is a decision table rule. This is a tabular, spreadsheet-like representation.
Okay, so columns and rows.
Exactly. The columns represent your input conditions and your output results, and the rows represent the specific rule execution paths.
And the second format?
The second is a text rule. A text rule is not tabular. It's a collection of rule expressions written out in a plain language, if-then-else format.
So let's take this out of the theoretical realm and actually build one.
Let's do it.
We are going to construct a determine approver logic table. The business scenario here is that we have thousands of sales orders pouring into our system from that API pipe we built earlier.
Right.
We need the system to dynamically evaluate the total cost of each order and the country it is shipping to, and automatically assign the correct management approver based on those factors.
Before you even open the rule editor, your very first architectural task is to define your data objects.
Right. The rules engine needs a vocabulary to work with.
Exactly. Based on our scenario, we know we need an input data type, the sales order data coming from the API, and an output data type, the approver, that the system is going to assign.
Let's create the output data type first. You create a new custom data type and name it approver.
And you need to give this object 2 fields to hold information. Both fields should be configured as the string data type.
You name the first field email and the second field user group.
Once your vocabulary is defined, you create a blank decision artifact. You name it determine approver.
You map the input to your sales order data type, and you map the output to the approver data type you just created.
Now the container is ready.
Next, we add a rule to our policy. For this complex multivariable logic, we are going to choose a decision table rule.
All right, we get our spreadsheet layout. Now we have to configure the conditions. We're writing the actual lines on the bouncer's clipboard.
Let's write line 1. In row 1 of your decision table, under the order amount column, you click in and select the comparison operator is equal or less than.
And you enter the numerical value 100,000.
Next to that, in the shipping country column, you need to check against multiple possibilities. So you use an array operator.
Right. You select existence and you enter the array of countries: United Kingdom, India, Germany.
So the if condition for row 1 is evaluating. If the incoming order is less than or equal to $100,000 and the shipping country matches any of the locations in that array, the condition is met.
Now we set the then result. If the condition is met, what does the system output?
Under the email output column, you enter john.doe@sap.com. Under the user group output column, you enter SOAP approver.
Okay, I have to throw up a massive warning flag right here.
Oh, the single quotes!
Yes. The source material highlights a very specific technical caveat regarding how you format those output results. And if you miss this, you will spend hours tearing your hair out trying to figure out why your project won't save.
I am going to stress this for you listening. For all string data types in these decision tables, you must mandatorily enclose the text in single quotes.
It is arguably the most common pitfall for new architects on this platform.
You cannot just type john.doe@sap.com into the cell. You have to type single quote, john.doe@sap.com, single quote.
If you fail to do this, the design console will immediately throw validation errors.
Why is it so picky about that?
To understand why, you have to think about how a rules engine parser actually reads your input.
Okay.
The parser evaluates the logic expressions. When it sees text without quotes, it assumes it was looking at a variable name, a data object, or a system command.
Oh, so it tries to execute it.
Exactly. It will search the entire project for an object named john.doe@sap.com, fail to find it, and throw an error. By wrapping the text in single quotes, you are explicitly telling the parser, this is a string literal. Do not try to evaluate it. Just output this exact text.
It's the difference between code and plain text. Right, so
Yep.
row 1 is configured correctly with single quotes. But let's stress test this logic.
Let's do it.
What if an order comes in for $150,000? Or what if it's a $50,000 order, but it's shipping to France, which isn't in our array?
Row 1 evaluates to false.
Right. The bouncer looks at the clipboard, doesn't see a rule that matches, and just stands there. The decision table returns nothing, and the process errors out.
Which introduces the concept of the catch-all row.
Yeah.
You must design your logic to handle edge cases and outliers.
So we add a row 2. You set the order amount column 2 is greater than 100,000. And here's the architectural trick. You leave the shipping country cell completely empty.
Completely empty.
Why empty?
In the SAP decision table parser, an empty cell evaluates as a wildcard. It acts as a universal true for that specific column.
Oh, I get it. So leaving that cell empty is telling the bouncer, if they are dropping over $100,000, I don't care if they're wearing sandals and a swimsuit, let them in.
That's exactly it. The logic reads, if the order is over 100K, bypass the country check entirely and apply this result.
That is incredibly elegant. And for the results of row 2, we will set the email output to john.doe@sap.com again, but this time we set the user group output to SOMGMNT.
Now, I want to pull on a thread here regarding that specific output. Notice that we are outputting both a hard-coded email address and a user group.
Right.
In a real-world production enterprise architecture, Hard-coding a specific human being's email address like john.doe@sap.com into your business logic is a massive anti-pattern.
It is exactly the disaster scenario we talked about at the top of the show.
Exactly. Because if John Doe gets promoted, moves to a different department, or leaves the company during the Great Resignation,
Your automated process is suddenly routing critical, high-value approval requests to a deactivated inbox. The system thinks it's working flawlessly, but the business has ground to a halt.
exactly. And to fix it, you would have to go into the process builder, open the decision table, find every instance of John's email, change it to the new manager's email, save it, release a new version of the project, and redeploy it.
It's a maintenance nightmare.
It really is. By outputting a user group instead like SOAP Approver or SOMGMNT, you completely bypass this problem.
Because the user group is an abstract container managed at the platform level.
Yes, the user group is an entity managed centrally in the SAP BTP cockpit by your identity and access management team.
Right.
When a new manager is hired, the IMM team simply adds their Active Directory profile to the SOMGMNT group in the cockpit. You never have to touch the decision logic, the decision table, or the process code ever again.
The automated workflow just routes the task to the abstract group, and BTP handles distributing it to whoever happens to be inside that group on that particular day.
That is the essence of a scalable architecture.
All right, let's take inventory. We have our actions encapsulating the APIs, securely pulling data in.
Okay.
We have our decision models dynamically evaluating that data and routing tasks to abstract user groups based on dynamic thresholds.
Right.
The factory is fully constructed and the machines are humming.
But a factory humming in the dark isn't doing the business any good.
Right.
If a chief supply chain officer walks in and asks, how many high-value sales orders are currently stuck waiting for management approval in the UK? And your only answer is, I don't know, let me go run a database query and parse the server logs. You have fundamentally failed as an architect.
You need operational visibility.
Which brings us to the control room. Let's look at end-to-end execution and process visibility.
Okay, so what's the first step there?
The first rule of deployment in this ecosystem is that anytime you make significant structural changes to a project, like adding new API automations or integrating complex decision tables, you must generate a new release and redeploy.
The release takes the immutable snapshot of your code.
Right. And the deployment pushes that snapshot out to the active runtime environment.
But the SAP source material emphasizes that simply deploying the process isn't enough. If you want that control room dashboard, you have to explicitly configure visibility scenarios.
Visibility scenarios provide the operational heartbeat of your automated ecosystem.
How do they work?
They sit on top of the workflow engine, listening for specific events, and they translate raw, back-end technical executions into business-readable, real-time dashboards.
Let's walk through building one of these dashboards, but before we do, there is a massive prerequisite check mentioned in the course quizzes that we really have to cover.
Oh, the desktop agent.
Yes. If your process includes any local automation steps, like a bot interacting with a legacy desktop application or manipulating local Excel files, you must ensure your SAP desktop agent settings are configured.
And the agent has to be registered and actively running on the target machine. This is a crucial architectural concept.
Right, because SAP BTP lives in the cloud.
Yeah, but sometimes automations need to execute tasks on a local on-premise machine inside a corporate firewall. The desktop agent is the bridge.
It sits on the local machine and constantly polls the BTP cloud, asking, do you have any jobs for me?
Exactly. If you trigger a process in the cloud, but the local desktop agent isn't registered, running, and listening, the process doesn't fail immediately.
What does it do?
It just hangs indefinitely in a queued state, waiting for a machine that is never going to answer.
That's a huge gotcha. Okay, assuming the agent infrastructure is healthy, let's configure the visibility dashboard. The first step is selecting the exact data context you want to monitor.
Right. You navigate to process details, then visibility, and you start adding the specific variables you want to expose to the dashboard.
Based on our sales order scenario, you would select fields like expected delivery date, order amount, order date, order number, order status, shipping country, and customer name.
You are essentially telling the monitoring engine, out of all the hundreds of variables moving through this process memory, these are the 7 metrics the business actually cares about.
Once a context is defined, you create the actual scenario object. You create a new visibility scenario and name it sales order visibility scenario.
Then you link your core order processing process to this scenario, establishing the connection so the dashboard knows which workflow to listen to.
And you set the instances label to sales order, which ensures the final dashboard UI reads cleanly for the end users.
With the scenario built, you go through the deployment cycle, you release the project to lock the version, and you deploy it.
And during deployment, if your automation requires local files, you provide the local file path for your testing data, something like C. Users download salesorders.xlsx, so the desktop agent knows where to look.
Right. Now we execute a live test through the pipe. You copy the trigger link for your deployed process, which typically opens a standard SAP web form.
You act as the incoming data source. You fill it out, entering SAP SE for the customer name and P07918 for the order number. You hit submit.
And the moment you hit submit, the engine roars to life. The process instantiates. The Actions project reaches out via the API, authenticates, and pulls the rest of the sales order data.
The workflow passes that payload to the decision table.
The bouncer evaluates the cost and the shipping country, determines that it exceeds the threshold, and routes an approval task to the management user group.
So as the architect testing this, I submit the form. The system is running. I immediately open up my new visibility scenario dashboard to see the data, and the dashboard is completely empty. There's no data, no order amount, nothing. Did I configure the data context wrong? Did the API fail silently?
This is a fantastic teaching moment because you didn't do anything wrong.
I didn't.
Nope. This behavior highlights the asynchronous nature of enterprise workflow engines and the realities of human-in-the-loop automation.
How so?
A visibility dashboard doesn't just stream raw memory variables in real time. It populates based on events and milestones.
Okay.
When your process hit that management approval step, the automated engine paused. It went to sleep.
Oh, because it needs a person.
Yes. It is now waiting for a human being in the real world to open their inbox, review the data, and click a button. Until that human action occurs, the current phase of the workflow instance isn't complete, and the data doesn't fully propagate to the visibility service.
It's a feature, not a bug. It forces you to realize that in a hybrid process involving both APIs and humans, automated doesn't mean instantaneous.
Exactly. To see the data, you have to complete the loop. You navigate to your SAP Build Apps lobby inbox, find the pending task named Supplier Acknowledgement, and hit Approve.
That wakes the engine back up.
Yep. The workflow finalizes its data collection, closes the instance, and reports the final state back to the visibility service.
And once I do that, I go back to the visibility scenario dashboard, hit refresh process data, and boom, the metrics populate.
They're there.
I can see the exact values mapped accurately. 150,935, 113 for the order amount, P07918 for the order number. The control room is online.
You now have a complete, functional, monitored ecosystem. But there's one final layer to this architecture, and it's the layer that truly separates a basic process builder from an advanced enterprise architect.
Oh.
You need to talk about what's under the hood, leveraging REST APIs.
We've spent this entire time talking about using APIs to pull data into SAP Build. We use an Actions project to reach out and pull S/4HANA data into our workflow.
Right, but SAP Build Process Automation itself exposes its own set of APIs. It allows external systems to reach in and control it programmatically.
These are REST APIs.
And while everyday business users will never interact with them, they will just use the standard graphical SAP inbox and the standard web forms. Developers and systems administrators rely on these REST APIs to integrate the workflow engine into the broader corporate IT landscape.
I want to challenge that, actually. The SAP GUI is incredibly robust. It has clean forms, a nice inbox, and easy-to-use buttons. Why would a developer completely bypass the user interface to interact with raw endpoints?
It really comes down to creating seamless user experiences across disparate platforms.
Give me an example.
Let's say you are a developer building a highly customized, branded human resources application for your company. Maybe it's a native iOS app designed specifically for executives to use on their iPads.
Okay.
You want that iPad app to be able to trigger a complex onboarding workflow in SAP Build.
Right.
If you rely on the standard GUI, you have to force the executive to close your beautiful iPad app, open a web browser, authenticate into the standard SAP web portal, and navigate through generic forms just to start the process.
That completely breaks the user experience. It causes a ton of friction.
Exactly. But if you use the REST API,
Oh, I see.
if you use the REST API, your custom iPad app can silently, in the background, compile the HR data into a JSON payload and make a secure post request directly to the SAP Build Workflows endpoint. The SAP workflow instantiates, the automations run, and the process kicks off without the executive ever leaving your custom app. It gives you raw, headless, programmatic control over the engine.
It's like the difference between driving a car and tuning the engine. Using the GUI is like sitting in the driver's seat with a steering wheel and pedals. It is designed for human comfort and standard operation.
Right.
But using the REST APIs is like a mechanic plugging a diagnostic laptop directly into the engine's computer block to adjust the fuel injection ratios. It is raw, direct, and gives you total integration control.
That is a perfect analogy, and SAP exposes several specific API packages on the Business Hub for exactly this kind of deep integration.
Like what?
You have the Automation Execution API, which allows external scripts to trigger your local bots. You have the Automation Monitoring API.
Let me guess, that's for admins who don't want to use the SAP dashboard.
Precisely. If your IT department uses a centralized monitoring tool like Splunk or Datadog to watch the entire global network, they don't want to log into a separate SAP dashboard just to check workflow health.
So they use the monitoring API to scrape the execution logs from SAP and pipe them directly into their master Splunk dashboard.
Exactly.
What else is exposed?
There is a Decisions API, which is brilliant for testing. It allows you to fire data directly at your decision table and see what it outputs, completely isolated from the rest of the workflow.
Oh, so you can test your logic without having to run a full end-to-end process instance.
Yep. And there is a Visibility Scenarios API, which allows you to push external events from non-SAP systems into your SAP dashboard, creating a unified control room.
So if you are looking to truly master this platform, your next architectural exploration should be navigating back to the SAP API Business Hub and finding the Workflows REST API package.
Definitely. Dive into the API reference, specifically looking at the Workflow Instances section and the PUST endpoint.
Because if you read that documentation, you will see exactly how the JSON payload needs to be structured and what specific OAuth scopes and security roles an external system requires to be authorized to pull that trigger.
It opens up an entirely new dimension of headless integration. Understanding how to expose and control your processes via REST is the defining characteristic of a composable enterprise architecture.
You are no longer building isolated workflows in a silo.
Right. You are building highly functional microservices that any authorized system in your network can leverage.
We have covered a massive amount of highly technical ground today. To synthesize this, I want to do a rapid-fire review of the key pitfalls and configurations we've discussed, directly mirroring the knowledge checks in the SAP course material.
Let's make sure the foundation is solid.
Let's do it. First, major pitfall: integrating an action project. Simply dragging the action onto your process canvas does nothing.
Right. You must complete two configurations. You have to map your process variables to the input parameters of the action, and you absolutely must define a destination variable so the process knows which technical address to route the API call to at runtime.
Second pitfall involves the rules engine. Do not confuse the formats. Text roles are not tabular.
Correct. Decision tables are your spreadsheet-like tabular formats. Text rules are collections of expressions written in a simple if-then-else format.
Third pitfall: project lifecycle. Creating an actions project and saving it locally doesn't help your process developers.
Right, releasing it creates the version snapshot, but publishing to the library is the mandatory final step to actually make it available for consumption in the process builder.
And the final pitfall, tying back to our execution discussion: before you attempt to run any process that contains a local automation step, you must verify your desktop agent settings.
Because if the agent isn't running and registered on the target machine, your automation will simply hang in the cloud waiting for a bridge that doesn't exist.
When you look at the entirety of what we have explored today, you can see the complete anatomy of a modern automated enterprise process.
Yeah, you really can.
You have learned how to build secure, encapsulated supply lines using actions. You have learned how to decouple your business rules from your code and evaluate data dynamically using decision models.
You've learned how to construct real-time control rooms using visibility scenarios.
And you have learned how to orchestrate the entire apparatus programmatically from the outside using REST APIs.
If you have internalized these architectural concepts, you have genuinely upgraded your capability as an enterprise builder. You aren't just bolting rigid machines to a factory floor anymore.
You are orchestrating a flexible digital ecosystem that can adapt to the market.
And the real power comes when you stop looking at these features in isolation and start combining them to solve highly complex, multi-system business problems.
But before we sign off, I want to leave you with one final provocative thought to mull over. We spend a lot of time today building a decision model based on static, hard-coded variables.
Right, like the $100,000 limit.
Yeah, if the order is exactly under $100,000 and the shipping country is exactly Germany, then assign it to this specific abstract use group. It is a powerful decoupled architecture, but the thresholds themselves are still rigid.
Very true.
As you look toward the future of enterprise architecture, how might you replace those static decision tables with dynamic, AI-driven rule sets?
Oh, that's fascinating.
Imagine an engine that analyzes real-time market volatility, supply chain disruptions, and global inflation, and adjusts its own approval thresholds on the fly without a human ever having to touch the clipboard.
That is the inevitable next frontier of composability, when the rules begin to write themselves based on the context of the world.
Something to think about as you continue to design and build. Until next time, keep experimenting, keep questioning the architecture, and keep diving deep.